Good day, ladies and gentlemen. My name is Alvin Naidu. I am the Managing Director of Altek Solutions in South Africa. Today at this Digital Innovations Conference, I am going to be presenting on the Drakenstein Municipality Control Center utilizing the ETAP SCADA. But first, I'd like to introduce Altech to you. Altech is the system integrator for ETAP and an eco-expert for Schneider Electric in sub-Saharan Africa. We are the leaders in electrical SCADA and substation automation. Our core competencies lie in the following areas: substation automation across multiple vendors, energy management, power system modeling, and advanced power system studies utilizing ETAP, Dixisland, eSCADA, electrical design work, model conversions, electrical maintenance, both HV and MV testing as well. So our locations are as follows. Our corporate head office is based in Johannesburg, South Africa. We have operations in Cape Town, South Africa. We have further operations in the Democratic Republic of Congo, and we have operations in Nigeria. Our customers belong to the following sectors. We do a lot of work in the mining space, both underground and surface operations, across multiple commodities, manufacturing with various commodities, and utilities, both renewable on the generation side and conventional, transmission and distribution. So I'd like to introduce the client for this particular project, which is Drakenstein Municipality, located in the Cape Winelands of the Western Cape in South Africa. They're actually made up of the following towns: Paarl, Wellington, Gouda, Suron, and Helmar. Drakenstein Municipality, from its electrical network perspective, has 9 primary substations and 40 secondary substations. The municipality has a combination of new and legacy substation equipment. Prior to this project, the customer had limited visibility of the electrical network, but what the client is currently undertaking is a lot of upgrades on the electrical network, changing the legacy equipment to newer equipment. So every project has a story, and I'd like to introduce you to this particular story of this project. So in January 2022, Drakenstein Municipality released a tender for a SCADA system, just for monitoring. So Schneider Electric, ETAP, and Altech decided, let's look at this project and let's offer this customer something that far exceeds your conventional SCADA system, bearing in mind what the customer's vision is. And the customer's vision was as follows: creating visibility of the electrical network, improving network efficiencies, reducing downtime, time of outages, and inadvertent tripping, and creating a comprehensive, unified, vendor-agnostic platform. Now, knowing the customer's vision in mind, this seemed like a home run for our solution. So we decided to conduct a presentation for the customer on our real-time offering, whereby we introduced the customer to PSMS and your various other packages that we have in the ETAP portfolio. Now, bearing in mind that the customer had limited visibility of the electrical network, we proposed a phased approach to a digital journey, as opposed to giving them all the bells and whistles that we had available, as your digital journey starts with baby steps until it evolves to the greatness that it becomes. So the customer was very impressed with our offering and portfolio, which led us to obtaining an order for this particular set of work. So here's what the digital journey proposal actually looked like. Creating visibility of 4 primary substations, integrating the multi-OEM system that they do have into a single unified, robust platform, integrating both newer and old technologies, the development and deployment of the ETAP model. Phase 2, creating visibility of all other primary and secondary substation, integrating control functionality on the system, and the integration of a smart load shedding system that we have in our portfolio. Now, phase 3, we integrate the ETAP graphical information system. We integrate the advanced distribution management functionality, integration of the outage management system, and the integration of the operator training simulation. This results in a robust digital twin with flexibility of a continuously evolving system, which has efficacy, efficiency, and usability at its fingertips. So for phase 1, as mentioned, these were the items that we were going to create for the customer. So during our design phase, we came up with 3 stages. The ETAP model development, where we had to create a model from scratch for the particular customer, not knowing what information the customer does have available. The hardware design, where we have multiple protocols that we're going to have to bring into a common system since we're dealing with legacy and new equipment. And how do we bring everything together on that unified platform? So in terms of the ETAP model development, our consulting team had their work cut out for them, as there was limited information available. What drawings our guys did have available, they were outdated. And so our team had to undertake walkthroughs at various substations, interviewing key personnel and stakeholders, as well as meeting and greeting electricians and people that worked at the facilities. But one of the key tools that helped our job immensely was the ETAP app, which accurately captured site information for the model development, which resulted in these amazing models being developed for the customer. So once we had our models developed and accurate information was inputted into the system, we decided let's optimize the network and verify it. So we conducted a load flow analysis, a short circuit study, and a protection and coordination study just to verify the philosophy that was available, which led us now to move on to the hardware design. So at the hardware design, at the substation levels for your newer equipment, we looked at utilizing IEC 61850 between IEDs and RTUs. From the RTU, we looked at utilizing IEC 60870-5-104 to the master station, which led us to an architecture like this. As we can see, we've got the SCADA master station, we've got the hot standby, we've got the operator workstation, the engineering workstation, and we've got the HMR viewers. At the substation levels, we can see that we're speaking IEC 61850 between the RTU and the substation equipment. And from there, we're utilizing 60870-5-104 to speak to the master station. Here's what our design looked like with your fiber layout. So for the legacy equipment, we handle things a bit differently. because we did have Modbus R2 available at certain points. So RS-485 was utilized. And for certain pieces of equipment where there was zero communication available, we utilized the hard wiring on the contacts with the appropriate voltage rating to the RTU. Now, at the RTU to the master station, we still maintained the IEC 104 protocol, which led us to an architecture looking. Here's some of our design work that we undertaken. As we can see, there's multiple converters that we've got along the way for your Modbus and serial communication, utilizing your 485 to 232 converters and so forth. So programming of these particular RTUs, we had 3 RTUs that we used in the system throughout the network. At each substation, these 3 types of RTUs was the ABB RTU 540, where we programmed accordingly for the various signals that we did bring into the system. We had the Schneider Cytel DR RTU as well. So on to the SCADA design. Now, at this point, what does the customer want? And how do they want to see things on their side? Well, what we looked at is, let's have a look at what interfaces they want and create these interfaces accordingly. So, the first interface that was created was the ETAP real-time interface, an amazingly beautiful, robust interface. We created the HMI viewer with advanced graphics for the customer. We created the web interface as well for your viewing packages. And what we went one step ahead and created the smartphone view. So coupled with these interfaces was particular viewing pages as well. Aside from your conventional substation viewing page and layout, we also created a communication viewer to basically view communication coming through from your RTUs and the health statuses of your particular RTUs. We created an alarm viewer for the customer. And with the alarm viewer, the customer was involved with us on the priority levels and the optimization levels of these particular alarms. Your event viewer, also the customer was involved with us for programming the various points and the events on that we view. Now, both the alarm and the event viewer, we also had it coupled to a notification system that went out to particular people. So the customer was involved in who receives what notifications at any given time. We had our trending view, and we had our tabular view as well. So the resultant was a unified platform that brought together information from the field into the model, into the SCADA system. So eventually we had what was on the field equals what's in the model equals what's in your SCADA system. A comprehensive vendor agnostic system that brought in information from multiple OEMs. And an optimized system for utilization. Finally, the system was created to be user-friendly to the most basic user up until the most advanced users. So what was the customer's impression points? So overall satisfaction was at a high. Customers involved with us from day one right until the final stages of phase 1 of the project. So every single decision, every single graphic was chosen and curated by the customer accordingly. Technical support was unparalleled. ETAP, Schneider Electric, and Altech collectively gave the customer the most immense technical support that you would ever find in any given field. System quality, well, the system was made up of the power system modeling, most advanced graphics that you'll find, and as well as your smartphone and other notification systems. So the system quality was immensely accepted by the customer. And ease of use. During the training sessions we had with the operators, electricians, and technicians, we found that they took to the system very easily because because of its ease of use and its usability for them. It wasn't a complex system. It was one of the most easiest systems created to be used. So in all projects, there's always some form of challenges. And these challenges I'd like to bring to light that were faced and how we managed to overcome them in the system. The digital transformation, as mentioned, creating that digital replica of the entire electrical network, whereby we utilize the ETAP app to capture site information when we undertook the model development. Vendor agnostics, well, ETAP was and is an absolute robust beast. So it integrated quite well with the multiple IED vendors, RTU vendors, and measuring equipment vendors that they had available. The technology in place, while creating a system that accommodated both legacy and newer technologies, was quite easy because of the robustness of ETAP and the communication protocol design that we did implement in the system. Being future ready. Well, having phase 2 and phase 3 in mind help us create the most future ready system available on the market. So in terms of the digital journey for this customer, with phase 1 being completed and phase 2 and phase 3 being on the horizon, it looks very prosperous and prospective for us, whereby customer acceptance for phase 2 and phase 3 being implemented in the future is imminent, and thus building the ultimate robust and flexible system that we do have in place. With the ultimate in the digital twin journey being from model to visualization, design and analyze, predict and monitor, operate and optimize, automate and control, being a continuous journey that we do have. One of the key parts of this project we did see driving this digital journey was working together with the customer as we are driving digitalization together. Creating a unified, robust platform for the customer is of utmost paramount to us. And the development of a future-ready system that's continuously evolving and ready to integrate with other systems is absolutely imperative at this stage. So from our side, with regards to this project, I'd just like to thank Drakenstein Municipality for affording us the opportunity to drive digitalization in the electrical network, as well as affording us the opportunity to showcase their ETAP experience. I'd also like to thank Schneider Electric for driving this project and providing unconditional hardware support. Most of all, we'd love to thank ETAP for their unconditional software support, training, and the opportunity to present this project at this innovation conference. And finally, in terms of a digital journey, if any of you looking to undertake it, some of the key things that we learned from this project is every digital journey is different and has to be tailor-made according to customer requirements and the current state of the electrical network. Customer involvement is of absolute importance as well, because once you start the digital journey, you need to be involved with it from day one because it's going to be yours. And one of the key parts with the digital journey is finding that starting point. Once you get started, the path becomes clearer in terms of what needs to be done. And finally, the road to optimization becomes easier once you've started this digital journey. And just to let everyone know, this digital journey never ends. There's going to be continuous model and visualization changes, design and analysis, predict and monitor, operate and optimize, automate and control. That's going to be added at every single stage, and it's going to be continuously evolving. The key is to get started. Thank you very much for your time, and I appreciate this opportunity for presenting. Should you look to contact me, these are my contact details. Thank you very much for this time. Goodbye.